So I'm going to be talking about Docker networking. So the caveat is that I'm by no means an expert on this, but when I was just through my various home fiddling, so I'm going to talk a little bit about containers and from a networking perspective how that actually works because I'm trying to figure this out myself. I quickly realised that not a lot of people out on the internet really know what they're talking about with this stuff. So they're not networking people, basically. So hopefully I can draw some analogies and sort of paint a picture of how it all works just from my own learnings. Um, so I've got a little setup here. So this is my laptop. There's a firewall in between, and then there's an inside LAN, and then there's a physical bit of tin which runs multiple VMs. And inside one of those VMs, which I've called VM Untrust, is a particular container that we're going to be testing with. So a little bit about containers. So just from the very high level and my observations of why you would do a container. So to me, they're just pre-packaged perfection, almost really. Like, so you have a developer who thinks of all the various dependencies and just pre-packages it, and you don't have to worry about environment conflicts and whether you got the right version of Python and all that. It's just self-contained. They're very lightweight, they're very small typically, and they can spin up and down in seconds as opposed to booting a whole operating system. So just think of a container as just a really well self-contained like application function. Now I've drawn a disk icon here just to demonstrate a really important point with containers. Typically what they term this is kind of like a runtime. So what that means is, for instance, it's very easy to upgrade the version. So for instance, if this is an Apache web server, so if somebody releases a new version of this, it's very easy just to go, kill the container, pull down the latest image, and then boot it up again, running the new version. But what about your persistent data storage underneath? Like, for instance, the test I'm going to have is going to have an index.html file. So what you actually do is you point inside the container to a location on the outer host's hard drive. So that's where we kind of are locating persistent stuff. So no matter what you do with container, so long as that mapping's still there, the files persist. So given that, we're going to do some demos. So I've kind of got three terminal windows up here. So this is my host. This is the blue Ubuntu host, the VM Untrust here. And when we get into it, we'll dive actually into the container as well, because they're all very distinct operating systems. So the first one is we're going to look at what images we've got, and we don't have any Apache one. So how you'd actually think to do that. So you basically there's a place called Docker Hub, which is basically just a massive repo of people's pre-built containers. And out of the years that I've been fiddling with it, I've never had to build one myself. It's very easy to do that, but if you want it, chances are someone's built it. And basically all you have to do is get one command once you've got your Docker environment set up, which is this one, Docker pull, and then it'll be the image name. So this is the official Apache image. So Apache is a web server. So what we just do is you simply just go Docker pull this, and this will take about 15 or 20 seconds to pull down. You can see they're coming down now. While that's coming up, we'll just flip back to the diagram. So what I'm going to show you is when this spins up, by default, it'll join a network called Bridge, and it's basically completely isolated. So if you spun up other containers, they would also be logically on this same network, the 172.17 in this instance. So container 1 can talk to container 2, no problems. And inherently on the bridge mode, you can get outbound access. So it allows like things to talk out. Now, you don't have inbound access, and this is what I'm going to sort of walk you through. So that's now finished. So if we do that, if we list the Docker images again, we can now see we've got this HTTP one. It's 10 days old. So somebody updated the repo 10 days ago. And incidentally, if you wanted to upgrade, that's what I was talking about before. Super simple. You just do another Docker pull, and it pulls the latest one, and then you've got a new container binary or not a binary, but build file to go off. So right, so now we've got that. So the next question is, how do you actually start it up? So docker ps is the command which shows you running containers. Now I've got a bit of noise in here just because I've my various other stuff that I've got running in my home, but you see there's no HTTP daemon one. So let's fire that one up and pull it from my clipboard. So you basically just say docker run, and the key thing is you point it at the image name, which links to what you've pulled down in the repo. So we've got some other stuff in here. Now the -v is for volumes, and that's what literally what I was talking about before. So this is that mapping from inside, which is anything from the colon onwards. So inside this container, the operating system is expecting this location to exist, and it's effectively like a link to the outside, and then this is just shorthand for present working directory, which basically means inside of this directory. Give it a name, and this just means detach, so it doesn't actually, I'll explain what that means in a sec. So when I hit enter on that, basically it's up. As quick as I hit that, the whole container has spun up and it's running an Apache web server. And if we list out the things again, the Docker images again, we can now see we've got a HTTP one, and you can see that it's listening on port 80 here. Now, listening is a little bit of a stretch at this point because we haven't actually done any networking, and I did this deliberately. So if we do, there's a Docker network inspect command with the name of the container name, and it spits out a whole bunch of XML. Or no, XML, that's JSON, I guess. And right down the bottom, you can see networks, it's a bridge, and here's what you see. So you can see it actually sets a gateway, which as I've indicated on the diagram is the router. Now I'm not sure if that's the best way to conceptualize that, but I'll come back to that. Certainly from the host point of view, remember this is a self-contained operating system. He thinks he's a full-blown operating system here. So we'll jump inside in a minute and show you. But he'll have a default gateway. He doesn't know he's a container effectively. So networking like anything else. So and it's got an IP address. So there's another command that we can do to actually inspect the Docker network, and we can say inspect the bridge, which is this network name here, and you'll be able to see the similar sort of information, but down here it also tells you the containers that are present on that network. And remember I said you can spin up multiple containers and they can all talk to each other inside of this 172.17.0.2 network. Okay, so I remember I said it is listening on port 80. We can actually do so if I'm on the outer host, we can for instance go telnet to the IP address on port 80, and that should get a listener back, which it does. You can see there's an Apache web server up basically ready to respond to that. But on the outside host, so my actual laptop, if I ping 172.17.0.2, that's going to fail because nothing outside that host knows how to get there. It's obviously that network isn't routed to or anything like that. So we haven't solved the problems yet. But so just bear in mind that. So if now we want to actually jump inside the Docker container itself, so there's a command called docker exec IT, and then you give it the name of the container you want to jump into, and then the command you want to execute inside the container, and that'll actually throw me inside the container. Now I'm actually inside, and I could try and do a ping 8.8.8.8, for instance, and that's not going to work. See, and this is a great demonstration of the pre-packaged perfection thing that I was talking about before, because people build them lean and mean, and they don't put any superfluous stuff in there, right? But for our purposes, we do want to add that superfluous stuff. So I'm going to use the package manager to install some network tools, basically, so we can just do some basic diagnostics. And the last one basically allows us to install ping. Yes. So this is now all inside this container. So now I should be able to ping. And hooray, we can. So what else have I got here? So we can also look at the routing table, for instance. netstat -rn, and you'll see, yep, it's got a default gateway pointing to that .1 address I spoke about. So you can see this is how it's actually routing outside the network. So what must be happening is I've put an outbound hide NAT address, because basically what happens is, as far as I can tell, it's a NAT that happens and it comes through and it will inherit the IP address of the, in this case, the virtual machine on the way out to the network, and any replies will be reverse translated back into it. So, so that's that. Sorry, I'm going pretty quick. I'm just trying to get through a bit. We can also, name resolution will also work. So if I ping cisco.com, for instance, that you can see that resolves. And I didn't actually configure any of that in terms of name resolution. So if we look at the DNS config inside the box, you can see that it's pointed to the name server, and like it's basically inherited this from the host. So you can see that all happens painlessly. So when a container comes up, you can expect that it can resolve internet host names effectively. So so that's that model. So that's outbound access. And so, but what about if we want inbound access and we want to actually publish a service? And I'm realizing we've only got 5 minutes left, so this is probably be where the example stops, and I'm more than happy to continue in a subsequent session, which will get to a more sort of multi-tiered example. But okay, so let's so if I then jump out here, and in order to kill the container, you just go docker stop the container name. And you can see that's booted me out of the inner shell because the container no longer exists. Now, incidentally, now that I've done that, remember I installed all those packages to get ping working. Next time I fire that up, that will be completely gone. So that only exists for the lifetime of the container, which in this case is now dead. So how do we publish a port? So using that same docker run command, I've just added a simple switch in here to say publish. And in this case, I'm going to say port 666 on the outside host, which is here, mapped through to port 80 on the inside host. So once we run that, and we go docker ps again, open type, you can now see that this is slightly different for those of you observant. This is all it said before. Now it's got this in front of it, which is basically saying listening on anything on the outside host on port 666 through to port 80. And now hopefully, and you can see I'm going to test this. So 10.1.3.50, which is 10.1.3.50 on port 666 from my machine. So it's going over that firewall. That should hopefully work, which it does. So that's now up and running. Let's see what else I just wanted to talk about. I've probably got time quickly just to talk about Docker Compose. So Docker run, these commands can get really long, like multi-line and quite hideous. So over time, something evolved called Docker Compose. So let me just stop those. Docker stop NSS web. And so stop just basically pauses it. It's like hitting the pause button, and remove just trashes the VM in totally. But now in Docker Compose, basically it's a similar thing, but it's declarative in a file. So for instance, let me just step through this. So a version number service. So basically this is the name of the container. This is actually what it's referenced to, like the friendly name. The image it pulls, which is from the Docker Hub, so it's effectively just this is a unique name on Docker Hub, and this is the volume mapping where it says the outer host location mapped to the inner host location, the inner container location, and basically you can tell it if it crashes, fire it up again straight away, and this is the port mapping thing. So once you've got a file like that, then you simply have to just go Docker Compose. Actually, let's just verify that that server's dead because I killed it. Yep. Docker Compose up and then -D to detach, and then it basically, it's going to do exactly the same thing. So hopefully that's running again, which it is. I'll probably take a breath. So hopefully that's a good intro. I'm more than happy to do another 15-minute session next time to go through a multi-tiered example.